But there's even more surprising evidence of sophisticated Neanderthal technologies.
The North's cold environment may have influenced Neanderthals' physique.
For centuries, scientists have puzzled over why Neanderthals, our tough, close relatives, vanished while we survived. They were strong hunters who ruled Ice Age Europe for 400,000 years. So what went wrong? Old ideas like climate change or fights with us didn't fully explain it. Now, DNA analysis has uncovered a shocking truth.
We found that Neanderthal DNA indeed does influence many traits in modern humans.
This video breaks it down step by step using hard facts from their genes. Stick around because the real reason they went extinct, revealed at the end, will surprise you. Let's get started. Neanderthals were tough survivors who showed up around 400,000 years ago. They had stocky bodies, perfect for staying warm in Ice Age Europe, and big brains, sometimes even larger than ours. These guys weren't just brutes. They adapted to freezing cold, hunting big animals like mammoths with sharp stone tools they made themselves. They mastered fire, built shelters, and even buried their dead with care, showing they had a softer side. For thousands of years, they ruled places like Germany and Spain. They were our close cousins, almost like family, living side by side with nature in a harsh world. But here's the thing that keeps scientists guessing. Why did they vanish while we kept going? That question's been around for ages, and it's time we dig into what happened next. Neanderthals were the kings of their world for a long time, holding strong for over 300,000 years. They thrived across Europe and parts of Asia, taking on brutal winters and dangerous hunts. But then, around 40,000 years ago, something changed. Their numbers started dropping fast, and soon they were gone. This happened right as Homo sapiens, our ancestors, began spreading out from Africa. The two groups lived near each other for a while, but only we stuck around. So, what wiped them out? That's the big question that's had people scratching their heads for years. Scientists used to point to a few ideas. Some said climate change hit hard. Making it tough for Neanderthals to find food as the weather flipped between icy and warm spells. Others thought competition was the killer. Maybe we outsmarted them, stealing their hunting spots or resources. Then there's disease. Could new germs brought by Homo sapiens have taken them down, like a cold they couldn't shake? These theories made sense, but they never told the full story. Bits of evidence didn't quite fit, leaving gaps in the puzzle. For decades, we've been stuck with guesses, piecing together fossils and tools, trying to crack the case. Now, though, a fresh discovery has turned things around. It's not just about old bones anymore. There's a new clue that changes how we see their end. Want to know what finally tipped the scales? Let's look at how DNA steps in to unravel this mystery next. So, why did Neanderthals disappear? To figure that out, we need to talk about their genetic code, their DNA. This stuff is like a history book locked inside their bones, holding secrets about how they lived and why they might have died out. Scientists have learned that ancient DNA, even from fossils thousands of years old, can still tell us a lot. It's not just random letters. It shows us what made Neanderthals tick, from fighting off sickness to having kids. Their genes are a big piece of this extinction puzzle, and they're finally giving us answers. One key part is their blood groups. You've probably heard of ABO types, like A, B, or O, and the Rh factor, which makes blood positive or negative. These aren't just for blood transfusions today, they mattered for survival back then. Your blood type can affect how your body handles diseases or even how well pregnancies go. For Neanderthals, their blood groups were a little different from ours. Studies show they had a mix of types, but one rare Rh setup stood out. It wasn't exactly like what most Homo sapiens had. This difference could have played a role in how they dealt with the world around them, especially when it came to staying healthy or growing their families. Their genetic profile was unique, but still close to ours. After all, we're cousins. About 1 to 2% of DNA in people from Europe and Asia today comes from Neanderthals, proof we're linked. Yet their genes had some quirks that set them apart, especially in how they adapted. While we're digging into this, it's clear their DNA wasn't just a footnote. It's the key to understanding their fate. So how do we even read this ancient code? That's where the next big step comes in, and it's all about cracking open their genome. Let's see how scientists pulled that off. Now that we know Neanderthal DNA holds the answers, let's talk about how scientists unlocked it. Decoding their genome wasn't easy, but it changed everything. Researchers at places like the Max Planck Institute in Germany took the lead. They started with old bones of over 40,000 years old, dug up from caves across Europe. One big site was Vindija in Croatia, where they found well-preserved fossils. These weren't just any bones. They were a gold mine for DNA, giving us a clear look at Neanderthal biology. The process was tough. First, they had to pull tiny bits of DNA from the fossils. That's tricky because old bones break down over time, and contamination is a huge problem. Modern human DNA from scientists or even workers who touch the bones could mix in and mess things up. To fix this, they built super clean labs and used special tools to drill into the bones, grabbing just the ancient stuff. After years of work, they hit a breakthrough. By 2010, the team, led by people like Svante Pääbo, had sequenced a full Neanderthal genome where billions of genetic letters were mapped out. This wasn't just a science win, it opened a window into how Neanderthals lived and died. Their DNA showed us their blood types, strengths, and weaknesses. It was like reading their life story, straight from the source. With this map in hand, we could finally start comparing them to us. So what happened when Neanderthals met modern humans face to face? That's the next part of the tale, and it's where things get really interesting. Alright, so we've cracked the Neanderthal genome. Now let's talk about what happened when they met us. Homo sapiens. About 50,000 to 60,000 years ago, our ancestors left Africa and bumped into Neanderthals across Europe and the Middle East. They didn't just wave hello, they got close. Really close. Scientists found solid proof of this in our DNA. Today, people outside Africa, like in Europe or Asia, carry about 1 to 2% Neanderthal genes. That's right, meaning bits of them are still in us, passed down from those ancient meetups. This interbreeding wasn't just a one-time thing. It happened over thousands of years as our groups overlapped. Neanderthals and Homo sapiens shared camps, swapped tools, and, well, had kids together. Those mixed babies grew up, had their own families, and spread those Neanderthal genes further. Studies show this mixing peaked around 55,000 years ago, based on DNA from fossils in places like Siberia. It added new twists to our genetic story. For us, it brought some handy traits, like tougher skin or better immunity to certain bugs. But it wasn't all smooth sailing, especially for Neanderthals. See, this mingling introduced new dynamics. Their DNA started blending with ours, but their gene pool was smaller, maybe only 20,000 Neanderthals total, compared to our growing numbers. That made a difference. While we kept expanding, their population stayed tight and isolated. This mixing didn't just share strengths, it stirred up challenges they couldn't dodge. They were tough, no doubt, but something about this clash left them exposed. How could such strong hunters stumble? That's what we'll dig into next, their power versus the hidden cracks that showed up. Keep watching to find out. If you're liking this video so far, give it a thumbs up and drop a comment with your thoughts, as I'd love to hear what you think about Neanderthals. Let's shift gears and look at how incredible Neanderthals really were. These guys were super predators, hands down. They didn't just hunt, they took on giants like mammoths and woolly rhinos, animals that could weigh up to 10 tons. Picture this, a group of Neanderthals armed with wooden spears tipped with sharp stones, closing in on a beast that could crush them in seconds. They didn't have fancy bows or traps. They got up close, stabbing and dodging, using pure guts and skill. Fossils from sites like France show spear wounds on mammoth bones, proof of their bravery. Their strength was unreal. Neanderthals had thick muscles and sturdy bones, which were way stronger than most of us today. Scientists say their arms were built for thrusting spears, and their bodies could handle the brutal recoil. They needed that power because meat was their lifeline. Studies of their teeth, like ones from Belgium, reveal they ate almost nothing but meat like deer, bison, and whatever they could kill. In a frozen world, plants were scarce, so they mastered hunting to survive. For 300,000 years, they ruled as top predators, thriving in places where others would have starved. This makes their disappearance even wilder. They weren't weaklings. They were built like tanks and hunted like pros. In a straight fight, they could have taken on anyone. So how does a group this tough just fade away? That's the head scratcher. Next up, we'll explore why these champs didn't make it while others kept going strong. You won't believe what tipped the balance. Now let's zoom in on the last chapter of the Neanderthals, the younger ones. Around 30,000 to 40,000 years ago, they were hanging on in places like Vindija Cave in Croatia. This wasn't their prime anymore. It was their final stand. By then, modern humans, that is us, were already moving in, spreading across Europe. The two groups lived side by side for a bit, maybe even trading a few glances or tools, but while our numbers grew, the Neanderthals were shrinking fast. Fossils from Vindija show just a handful of them left clinging to survival. Their population was tiny, as some guess, as low as 20,000 across all of Europe. That's not a lot when you're spread over huge areas from Spain to Siberia. They lived in small, scattered groups, often cut off from each other. Caves like Vindija tell us they were isolated, with fewer chances to mix or grow. Scientists found their bones there, some of the youngest ever, dated to about 32,000 years ago. These were the last of their kind, holding out as the world changed around them. But something was off. Biologically, they weren't bouncing back like we were. This shrinking act wasn't just bad luck. Their bodies and genes were hitting limits we didn't face. They'd been tough for ages, but now they were cornered, with modern humans thriving nearby. What held them back when it mattered most? That's the edge of the story we're about to hit. Stay with me. The big answer's coming up next, and it's going to flip everything you thought you knew. Okay, we're at the heart of it now, the great mystery. Neanderthals were absolute beasts. They hunted mammoths, survived ice ages, and outlasted crazy weather for over 300,000 years. Their strength and smarts kept them going when life was brutal. But then, poof, they're gone by 30,000 years ago, just as we modern humans take over. How does that even happen? Their extinction's been a head-scratcher forever. Were they too tough to fail, or was something sneaky at play? Let's break it down. For years, people had ideas. Maybe climate change dried up their food. Those cold snaps hit hard, dropping animal numbers. Or perhaps we outfought them, grabbing their caves and hunting grounds. Some thought diseases we carried wiped them out, like the prehistoric flu. Those theories sounded good, but they didn't add up completely. Neanderthals were too good at adapting, and fossils show they hung on through tough times before. So, what's the real deal? Recent studies flipped the script, pointing straight at their genes. DNA's where the truth hides. Here's the tease. Their blood groups might have been their Achilles heel. Scientists found Neanderthals had a rare setup, especially with the Rh factor, that didn't match ours. When they mixed with us, which they did, that mismatch could have caused big problems, especially for their kids. It's not about battles or blizzards, it's about something quiet, deep in their biology. What was it? We're so close to the answer now. Let's see how modern humans turn this into our win. That's the next piece, and it's a game changer. So, the mystery's heating up. Now let's talk about us modern humans and why we came out on top. When Homo sapiens left Africa around 60,000 years ago, we weren't just lucky. We were flexible. Our DNA was a toolbox packed with variety. Take our blood types, A, B, O, and the Rh factor. They weren't all the same, they mixed and shifted fast. That diversity helped us big time. Some types, like O, made us tougher against diseases such as malaria, which hit hard in new lands. Others let us adjust to weird climates or strange food as we spread out. Neanderthals? Not so much. Their genes stayed pretty stuck. Studies show their blood groups, especially that rare Rh setup, barely changed over thousands of years. While we evolved quickly, adapting to bugs and weather, their Rh-negative blood was common, unlike the mix we had. That worked fine when they were solo, but it turned into a problem when we started mixing. Our numbers grew, with some saying we hit 100,000 while they dwindled to 20,000. We kept pushing, learning, changing. They couldn't keep up, locked in their old ways. This edge wasn't about fighting or smarts alone. It was biology giving us a boost they didn't have. Our adaptable genes let us roll with the punches, like new sicknesses, icy tundras, you name it. Neanderthals' static DNA left them exposed, especially when our paths crossed. How did that seal their fate? It's all coming together now. Stick around as the final piece is about to drop, and it ties everything up. Here we are, the big reveal. Neanderthals didn't vanish because of storms or lost battles. DNA tells us the real story. It was a hemolytic disease of the newborn, or HDN. When Neanderthals and modern humans had kids together, their blood clashed. See, many Neanderthals had Rh-negative blood, while we often had Rh-positive. If an Rh-negative Neanderthal mom carried an Rh-positive baby from a human dad, her body fought back. It made antibodies that attacked the baby's blood, causing anemia or even death. Today we fix this with a shot, but back then, no chance. This wasn't a one-off. It happened over and over as we mixed, starting 50,000 years ago. Scientists found this in their genes as studies from 2021 at places like Aix-Marseille University pinned it down. Each lost pregnancy or sick baby cut their numbers. Neanderthals were already few, with maybe 20,000 total, while we kept growing. Over generations, this hit them hard. Their reproductive success tanked, and they couldn't replace who they lost. We thrived, hitting 100,000 or more, while they faded to nothing by 30,000 years ago. It was quiet, slow, and deadly. A biological trap they couldn't escape. DNA cracked this case wide open. Old bones from caves like Vindija spilled the secret, showing how their rare Rh blood turned interbreeding into a curse. It's wild to think something so small decided their fate. That's the power of genetics, unlocking a mystery 40,000 years old. We've reached the end. If you enjoyed this video, like and subscribe for more content. Comment below with your thoughts on Neanderthals. I can't wait to read them.